Now, after completion of this earlier diagram, then the catalyst will having that, what about the phenomenon is there? Two types of phenomenon it will be takes place. One is selectivity, another one is activity it will be takes place. Next, the types of catalytic process. The catalytic process will having the two types of catalytic process it will be takes place. One is activity, another one is selectivity. Now, in the earlier what we have discussed about that homogeneous catalyst, heterogeneous catalyst and autocatalysis. Homo means same, hetero means different. Homo means same and hetero means different. Will having the different phase it will be takes place, it's called as heterogeneous. If it will be having in the same phase it will be takes place, it's called as homogeneous catalysis. And another one is autocatalysis. Auto means self. Self means in the reaction it will be having the intermediate product will be generated. That intermediate product act as autocatalysis. The best example is earlier we have discussed about potassium permanganate reacts with oxalic acid condition. Next one is mechanism and after that is selection of the process. Here activity, the catalytic property, two types of process it will be takes place. One is activity, another one is selectivity. One is activity, another one is selectivity. If you see that activity, activity means the process of the reaction will be enhanced, that is called activity. Generally that fifth group to seventh group of element it's act as a activity it will be takes place. Which activity? Catalytic activity it will be takes place. And another one is D block elements is also will having more activity it will be takes place. Activity means rate of reaction will be enhanced by using the catalyst, that is called as activity condition it will be takes place. That activity condition is best example is hydrogen reacts with oxygen to form H2O. Here the activity condition react with hydrogen gas reacts with oxygen to form H2O, water formation H2O. In this condition the activity is enhanced by what about the one of the catalyst, that one of the catalyst is platinum. Now the selection of the reaction of the condition is activity. Another one is selectivity. Selectivity means the reactants are same, that products are different. Reactants are same, product are different by using the sum of the catalyst, by using the sum of the catalyst, that is called selective. Selective means if you take any materials, the catalyst will be variable. By changing of the catalyst, automatically product is also variable. So the type of phenomenon is called as selectivity. Selectivity means changing of the product. For example, carbon monoxide plus hydrogen. Carbon monoxide plus hydrogen, it forms methane. It forms methane gas and another one is H2O. another one is H2O. This is the what about the one reaction, means carbon monoxide reacts with hydrogen gas to form methane and water. In this condition, if you are observing that the catalyst is nickel is the catalyst. The catalyst is nickel. So, carbon monoxide is gas, hydrogen is also gas, methane is also gas, and H2O is also in the vapor phenomenon. The reaction, if you balance that condition, how many hydrogens, one carbon is there, one carbon, hydrogens are 2, here how many hydrogens are there, 4 plus 2, 6 hydrogens are there. I am taking here 3 moles of hydrogen. By taking the 3 moles of hydrogen, it is converting as methane and water. Now, this will be takes place, which catalyst? This will be takes place by the nickel catalyst. The product is methane and water, it will be formed. Carefully observe, 1 mole of carbon monoxide reacts with 3 moles of hydrogen, it will be formed. Next, another one is carbon monoxide plus hydrogen. Next, another example is carbon monoxide plus hydrogen reacts with each other to form formaldehyde. To form formaldehyde. To form formaldehyde, this is the product. Now, see that carefully, you can observe that. What are the reacting molecules? The reacting molecules are carbon monoxide is there and as well as hydrogen is present. Carbon monoxide gas is there and hydrogen is also gaseous material. These are the material reacts with each other to form formaldehyde. This reaction is takes place by the catalyst is copper. The catalyst is copper. See that this is the selectivity. This is meaning of selectivity. How it will be treated as selectivity? Selectivity means the reactants are same, but products will be variable. By changing the what about this catalyst? By changing the catalyst, the products is also variable. Changing the catalyst, product is also variable. Carefully observe. Carbon monoxide, here also carbon monoxide is there, hydrogen, here also hydrogen is present, but products are variable. Here the methane is the product, here formaldehyde is the product. Products are variable, but here catalyst will be variable. Reactant same, products will be variable. On what condition? By using the or by changing the catalyst. When nickel catalyst is there, methane is the product. When copper catalyst is there, formaldehyde is the product. So, this is called as what about the selectivity condition. By using the selectivity, we can have the identify the reaction. And one more condition here, carbon monoxide plus hydrogen to form methanol is the product. To form methanol, methanol means CH3OH is the product. Here the catalyst is copper plus and zinc oxide act as a catalyst. So, carbon monoxide reacts with hydrogen to form the product. The product is methanol. Methanol is CH3OH. Now, in this condition, if you are see that the catalyst is copper and zinc oxide is the catalyst. Copper and zinc oxide is the catalyst. To balance the reaction, here one carbon is there and one oxygen, here also one oxygen, 3 plus 1, 4 hydrogens are there. If you are writing here 2 hydrogen, carbon monoxide is gas, hydrogen is also gas, methanol is also gas. Now, this one is belongs to the condition. See that here, what we have to observe here in this first reaction, second reaction and third reaction. First reaction, second reaction and third reaction. By changing the catalyst, that is called selectivity, product selection is takes place. To select the product, which product we require, either methane product or formaldehyde product or methanol, which product we have to require, like that based on the requirement we have to use the catalyst. By using nickel catalyst or copper and zinc oxide catalyst. So, this phenomenon is known as selective catalyst. Another best example for selective catalyst is zeolites. You know very well the zeolites are using as a purification of water. Zeolites are using purification of water. The formula of zeolite is Na2O, sodium oxide, Al2O3, aluminum oxide, X SiO2, X moles of silicon dioxide, Y moles of H2O. In this zeolite, this is called as zeolite bed. In the zeolite bed, the exchanged ions are sodium ions are exchanged. Na2O, Al2O3, X SiO2, Y H2O, and another one is in the ion exchange process. In the ion exchange process is also what we are using different type of what about the purification beds we are using, that is called as catalytic bed, another one is analytic bed. So in this process what we are using synthetic resins. Resins means filtered compounds are called as resins, that synthetic beds if you are using, and that condition that zeolite beds act as what about this filtrating material. It is also selective process. If you see that catalytic in the zeolite process, here sodium ions are exchanged. Sodium ions are exchanged means only calcium in the hardness of water, calcium ions, magnesium ions are present, and another one is chlorides, sulfates, nitrates, bicarbonates are present in the whatever the solution. These are the major components are causing for the hardness of salt, hardness of salts. To remove of this hardness we are using zeolite. Is the zeolite is honeycomb like structure, it is a fixed structure, it will be takes place. The fixed ions, cations area only cations are observed, but anions are not observed. In anions area only anions are observed, means it is a selective process. When you pour the hard water consisting of cations are present, anions are present also there. So first chamber is cationic chamber, second chamber is anionic chamber. In the first chamber only cations are filtered off. Anions are what about this penetrate, anions are what about the travel into the zeolite bed. It means what? So only the zeolite bed is specifically designed for that type of materials only attracted, but not other material. So only cations will be attracted. It means only cations is attracted means it is called as selective. Selective means that type of ions only what over the trapped in that material, and remaining materials are filtered out. Again it will be entered into the anionic chamber. In that anionic chamber only anions are trapped, remaining materials are escaped out. So that is called as selective process. So that bed is called as zeolite bed. It's what type of structure? It is a honeycomb like structure. To enhancing the zeolite property, that will having that different type of measurements it will there, that is ZSM5, ZSM7 like that. ZSM zeolite synthetic membrane, ZSM that in the books they are using as a short form ZSM5, ZSM6, that is 5, 6, 7, that is the range of the material and the preparatory whatever the range of the material. Z indicates zeolite, S indicates synthetic, M indicates membrane. Zeolite synthetic membranes are fixed structure. If enhancing the activity of zeolite, we have to heat the material. When you are heat the material, in that zeolite will having any water molecules are trapped. Water molecules are trapped means water molecules అందులో లాక్ అయి ఉన్నాయి అనుకోండి. If you are heat the material, those water molecules are escaped out from by the evaporation process. Now the zeolite bed is in the dry condition, it will be takes place. When it will be having the dry condition, its activity is more and only that particular ions are filtered out. So that is the major advantage of this selective process, that selective catalytic properties are by using the technique of adsorption by the zeolite bed. So this is what about the selectivity. Activity means enhancing of the catalytic function is called activity. Selectivity means only particular ions are what about the trapped out on that particular condition, it is called as selectivity. Why we are using this selectivity is discussed in the surface chemistry, means the materials are whatever the struck onto the surface of the material only. So surface of the material means it is called as adsorption phenomenon, it will be takes place. So that is the reason the catalytic materials is also act adsorbent phenomenon. So that is the reason we are discussed in the topic. Another one is catalytic property in the enzymatic action. You know very well enzymes. The enzymes are our body or biological function, enzymes are takes place. Those enzymes are will having that more nitrogenous materials. Nothing about the enzymes will having that will form the different type of biological function, it will be takes place. In that selectivity conditions I am using another word is enzyme. Catalyst means enhancing the property. Those catalysts are activity is there, selectivity is there. For this selectivity process I am using another word that is called as biocatalysis. In that biocatalysis we are using as enzymatic action. In our body, will having that made by different type of whatever the amino acids. Those amino acids are will having the more nitrogenous mixtures. These every nitrogenous mixture, every gland will having the its own function, it will be takes place. Of course, several mechanisms, several functions are takes place in the body, but every enzyme is a schematic or designed for only particular purpose only. For example, urea is urease converting material, urease material only urea function it will be takes place. And yeast material will having the sucrose material and diastase material, invertase materials, maltase materials, all the enzymes are will having only one function it will be takes place. Of course, it is there in the body, but it will be do the only one type of function. So, that is called as selectivity of the material. Every enzyme will have the only one type of function it will be takes place, only on that particular area it will be reacted. So, that is called as enzymatic action. Another one is what about the selective property of the enzymatic condition. For example, if you see that invertase enzyme, the source is yeast. Yeast source is invertase. Yeast source, where it will be source? The yeast source is invertase enzyme. This invertase enzyme will do the functions of sucrose converted to glucose and fructose. This yeast will having the, when you are having the yeast material, the enzyme is invertase enzyme. The invertase enzyme, the function is, invertase enzyme function is sucrose. Sucrose formula is C12H22O11. Sucrose is the material. The sucrose material is converted to glucose and another one is fructose. It is converted to glucose and fructose by using which enzyme? Invertase enzyme. If you are not using the invertase enzyme, the enzymatic action will not be takes place. Another one is another yeast source of enzyme, that is zymase enzyme. It converting as glucose. That is another source of yeast enzyme is zymase. Another source is zymase. That zymase material, the enzyme is zymase material. The zymase material, the glucose is converted to, the zymase material glucose converted to ethyl alcohol, glucose converted to ethyl alcohol and carbon monoxide. Means glucose material is C6H12O6. The C6H12O6 is converted to ethanol, ethyl alcohol. Ethyl alcohol means it is called as ethanol. The formula of ethanol is C2H5OH. The glucose formula is C6H12O6. Glucose material, by using the zymase enzyme, it is converted to ethanol. So, this reaction we are using in the preparation of alcohols also. In the preparation of alcohols also, this reaction we have to use. Ethanol is a alcohol. Alcohol means nothing about spirit. The spirit material is ethanol. That is the whatever the preparation of alcohol. Which enzyme is used? Zymase enzyme is used. See that the yeast source are two types of enzymes are there. Yeast source, one is invertase enzyme, another one is zymase enzyme. The source material, what is the source? Where it will be obtained? The source of the material yeast material. Invertase converted to sucrose to glucose and fructose, and zymase is converted to glucose material, ethyl alcohol and carbon monoxide. Another one is sucrose starch to maltose, that is malt, that is diastase enzyme. Another enzyme is diastase. The diastase enzyme is, that is malt, the source is malt. In that material it is converted to maltose to glucose. Another material is urease, that is urea to ammonia. Another material is pepsin. In the stomach it will be there. It prepare the material proteins to amino acids. So, here our proteins, what we are taking the food material, the protein materials are converted to amino acids. Protein materials are converted to amino acid by using the material or enzyme is pepsin enzyme. That is pepsin material converted to proteins. What are the protein? What we are taking the food materials will having the protein part, it will be there. Those protein parts are converted to amino acid. That is amino acid RCHNH2COOH. Means amine group is present as well as acid group is also there. So that amino acid preparation we are using. Another one is curd material, lactose to lactic acid, that is called lactobacillus enzyme. That material is lactobacillus curd preparation. In that curd preparation, lactose to lactic acid, that material is curd preparation material, that enzyme is lactobacillus enzyme. So that lactobacillus enzyme, it acts as a condition. Another one is trypsin. Trypsin is in the intestine, it will be there, and proteins are converted to peptides. Proteins are converted to peptides. Proteins are converted to peptides. That enzyme is trypsin enzyme. That enzyme is trypsin enzyme. This one is what about the schematic and enzymatic action, it will be takes place. Now today the topic what we are discussing is here. In the last class we are discussing that catalytic property we are discussing. Now today the topic is we are discuss about that catalytic. How many types of catalysts are there? The types of catalysts are two types of major representation is there. Homogeneous catalyst, another one is hetero. Homo means same, hetero means different. What is same? Catalytic means in the reactant and product will having the same catalyst is present, that is homo. Reactant and product, if different phenomena are there, that is heterogeneous catalyst. Another one is what we are discussed about, that mechanism of catalytic action. Mechanism, how catalytic will be function. According to adsorption theory only, catalytic function it will be takes place. Means the reactant molecules are deposited on the surface of the material, then the reaction will be takes place and the product will be formed by taking the energy. So that is the mechanism. And another one is activity and selectivity. To enhancing the rate of reaction of the material of the reaction, the activity it will be takes place. The activity depends on what we are using the catalyst. Selectivity means reactants are same but products are different. Reactants are same but product. When reactants are same, products are different on changing the catalyst. On changing the catalyst, if you are change the catalyst, automatically catalytic function will be variable. And another one is, now the last one what we are discussing about, that selective catalyst is zeolite beds we are using for the selection of the trapping of the cations or trapping of the anions. That selective catalyst we are using. And that last one what we are discuss about today is enzymatic catalyst. Every enzyme will have the systematic function or systematic work it will be takes place. So that is different enzymes will have the different functions it will be takes place. Like yeast is the source, and what about the source material yeast? The enzymes are zymase and invertase enzyme. Zymase converted to glucose to ethanol and carbon monoxide, invertase enzyme converted to sucrose to glucose and fructose, and pepsin material converted to protein to amino acids, and curd material, that is lactobacillus material, converted to lactose to lactic acid. Protein materials are converted to peptin, that is diastase enzyme. Another one is urea material converted to amino acid, that is called a urease enzyme. Like these are the enzymatic functions are takes place. And another one is characteristics of enzyme, and those catalysis will be having the discussed in that tomorrow's class. Next, all of you, what we are reading and what we are learning in the last class and today class, and take your volumes and do the assignments in that particular different levels will be there. Those particular answer how to do it, that is more beneficial for you. Because of on the continuation, if you are read it and automatically do the different type of applicative problems and different type of modules, you have to cover it, automatically will be perfect. Otherwise, it's so difficult to understand the thing. Thank you.